So, hello everyone. Is my slide visible? Anyone? Okay. And I'm audible, right? So, welcome to the first practice session of the Geographic Information System. So, I hope you have seen the first week lectures from the uh, course instructor, which is Professor Bharat. And okay, okay. Yeah, it's not audible. Okay, now it is. So sorry for that. So I am Akansha Kumari and I am a PhD scholar at the University of Queensland and IIT Delhi. And I'll be like at every week on Saturday at this time, we'll be having practice session on this course, Geographic Information System. And the main aim of this session is that you ask questions. Okay, so you have to ask questions if you have from the week lectures or any previous lectures related to this topic, and I will try and answer that. And also, I'll be giving some questions with some options. Mostly, it will be objective type question or numerical questions, and you can try to solve it. And then what I will do, I'll show what like how can you solve it and what are the basic concepts that you need to know for solving this type of problem, so that I'll be giving. Okay, so I hope that we can keep these sessions as interactive as possible, so that like you get most out of it. Okay, so should I start or any questions right now? Okay, so let's start. So first of all, we should know why we should study this geographic information system. So let me check if something is submitted. Okay, so let's start. So what is geographic information systems? So it is basically geographic information is data about the location, which is geographic, and what is there at that particular location. Okay, so basically, in simple word, geographic information is kind of information about a location and some related properties to it. And there are some like key technologies that are associated with geographic information system. So one is global positioning system, which is called as GPS. So in your mobiles, like everyone is kind of using this GPS system to get to, like if you want to go to some place or a university and you don't know the way, you can use the GPS system that is there in your mobile phones, and then it will give you the location, how can you go there. Okay, so this GPS system is there. Then we have remote sensing. So remote sensing we will study in detail, because this is how the satellites, from the satellite images we get information. So the technology behind the satellites, like how they take information or images of the earth, that is remote sensing is. And then the third is geographic information system. So this is basically like combining these two, whatever satellite images that we have, from that we extract information. So this geographic information system is very useful. And from like for this course, what I will try to do, we will be having some hands-on sessions also. So I'll be using QGIS, which is like open source software which you can use. So, and there is another ArcGIS. So if your university or institute provides the license for that, then you can use ArcGIS also. So basically, we will be using QGIS and ArcGIS, both of them, for uh, like how you can process the satellite images and extract the information. We'll be also like solve some case studies or look at some case studies and get the satellite data, download the data and do some processing, like getting vegetation index, NDVI map, land use, land cover map. So those things we will like do using QGIS or ArcGIS. So I'll try to keep like our sessions such that you can learn how to use these softwares. So once I use these like softwares, what you can do, the recording of these lectures will be available, and what you can do is that you can um, try to do those steps, and if you have any problem in those steps, then what you can do, you can ask me in the next session, like what doubts or at which step you are stuck. Okay, so the main thing is you get most out of it. So that is what I aim. Okay, so any doubts you can ask. So now I have a question. So here you have to match with their correct technology. So I have basically provided simple definition of these terms, which is remote sensing, GIS, and GPS. So you have to, like, in the chat box, you can write A is related to which one of these, B is related to which one of these, and C is related to which one of these. So A is real tracking of buses. So what can be the answer? It's very simple. Okay, GPS. Yeah. Um, so correct. It is GPS. Now B is classification of land use from satellite images. What is that? Remote sensing. Correct. Now third is buffer zone creation. So it will come into geographic information system. Okay. So it's good. Like we are on track. We, all of us are together. So we'll move on to the next one. So the U in GPS stands for, it's kind of a trick question. None of the above. Correct. Ah, it was a trick question. There is no U. Okay. So now we'll move on to remote sensing. So like in today's class, I'm like giving you some basic concepts, and from the next class we'll like align more with the courses. Okay. So, how many of our five sensors we use as remote sensors? So you can, like, we have five senses, right? So in these, how many are acting as remote sensors? Like you can give me number one, two, three, four, five. How many? Three, three, two. Okay. So we have like a range now from 1 to 3, I guess. Okay, so let's see. So what is remote sensor? So remote sensor like comes from two words, remote and sensing. And remote means far away, and sensing means feel, measure, or understand. So basically, remote sensing means sensing things from a distance. So, like the best remote sensor that we have is our eyes. So, right now, if you are looking at the screen, what is happening? The light is like uh, getting reflected from the screen and then coming to our eyes. And we are not touching the screen, like we are very far away from the screen. Still, we are able to um, get get information about what is written on the screen, and our brain is kind of like processing. Uh, you can't see this page. Okay, so is that a problem with everyone? My screen is visible, right? It's not? Okay, okay, it's visible. So I think that is a problem with like not my side, with your side. So let's see. Yeah. So you know how this works, remote sensing. So our eyes are kind of best remote sensor that we have. And then hearing is also a remote sensor because you are not getting in contact with like what you are like electromagnetic waves and these vibrational waves, like these are the ones that are reaching to your eyes, sorry, ears. So that is how you are able to sense it. And smell, so these three are the ones where you are not touching the target. So that is why these three are remote sensors. So now I'll move on to basic components of remote sensing. So first of all, there is a source of energy. So basically for Earth or most of the like satellite images that we have, we like the sun is giving the electromagnetic energy. So this is source of electromagnetic energy. And then this energy travels through the atmosphere, and then it interacts with the target, and then again it will travel uh, through the atmosphere, and then there are detectors there on the satellites which will measure the properties that we are interested in. And then after this particular uh, information is given to a ground receiving stations, and this ground in the ground receiving. Okay, so actually I need to see the chat box, so I'll just place it somewhere where you don't have much information. Okay, so you can see, can you see my cursor? So it's somewhere here in the image. So what happens is that you have some ground receiving stations where you get these satellite information or images, and then those images are processed, and then we use it for various purposes. Okay, so monitoring, and so you can see this is our Earth, and there are lots of satellites like revolving around it. And what they do, they give like different like layers of information. So, like you can get information about the soil properties, you can get information about like lots of things. And there are different images that you can use for your like the kind of image that you will make will depend on what you are trying to do. Okay, so if you are interested in understanding the land use, land cover, how it has changed over the past, or urban expansion, then you will make different kind of images. Okay, so and then with these images, we make like these kinds of plots, which are easy to understand and easy to look at the patterns uh, for like viewers or users, like based on what you are trying to do. Okay, so this is what we do. And yeah, so actually, I have placed it because I want to see your like if you have any doubts, I can see, right? So if it is placed somewhere here, like there is nothing it is hiding. And if you follow like wherever I'm going or whatever I'm teaching, uh, you should see there only. So you can see that information. Um, and when I'll move to the other side, I'll just move this chat box. Because like if I can't see what you are like if you have any questions or doubts or any problem, I can't see like every time I have to go back to this particular tab and see what you are saying. So that is why I have placed this chat box. So is it okay now? It is not covering the full slide, right? Yeah. So yeah, it is just for me to like I also want to interact with you guys, so it should be like there. Okay. So now we will see and make it small. Okay. So what is GIS? So if we look at the definition, it is a tool which like you can have large volumes of spatial data. So spatial data means you have data for different locations all together. And then what you can do different kinds of analysis based on user, like what you are trying to do. So you can see this is the real world which we will be looking at, and this is the kind of image that we can make. So real world is very complex and it has like lots of features, but based on what feature or what property we are interested in, we will be make that type of images. Okay, so here it is kind of topographic base. Here we have flood plains and wetland area. This is land cover, land use, land cover, then soil map. So based on what you are interested in, we will take or we will take those properties only from the real world and then map it to the GIS world. Okay, so real world is kind of this, and in GIS world we have like lots of layers of the real world. Okay, so the slide is not moving. Okay, so if you are like interested in this field, like this is kind of multidisciplinary field. So there are lots of experts that who use geographic information system technology. So in surveying, in remote sensing, in like statistical work or commercial data processing. So lots of people or experts use these kinds of like this GIS technology. And for this technology, you need lots of things like you need software, you need the data. So we'll also look at different links like how can you download different kinds of data and like you need a network of all these things. Okay, so it is kind of organized collection of these five things. Okay, so we'll get the feel of this whole GIS technology once you start using QGIS, because then you will be dealing with some problems or some data, and you will try to extract information from that data and map it uh, so that we can get the pattern. Okay, so once you will start using QGIS or any like GIS software, then you will get a feel of it, like why it is very important. Okay, so we'll skip this. So now what are the applications that you can think of? Like, I'll just hide this, use this chat box, and you can write like how or what are the applications of this geographic information systems that you can think of. Anything or any particular problem that you are trying to solve using GIS system, or anything that you want to learn from this. Anyone? Write something. Flood analysis or like anything. Okay, so let me give you the answer. So first is natural, like there are like each country they are like uh, uh, they have lots of satellites revolving around the earth. So why they are sending these satellites? So because these satellites can monitor lots of things, and the images that we get from the satellites, using these GIS tools we can extract the information from those images or those data sets. Okay, so what are the kinds of information that you can get? So first is that natural resource management. So you can get information about the resources or natural resources from like far apart. So based on the properties uh, of the, like what we do is basically we have lots of indices like for identifying a particular type of rock or a particular type of thing. Okay. Mm, so I have admitted. So I'll make this like tomorrow I'll make this such that you don't have to ask me for admitting you, so that it is smooth and it will not interrupt the class. Mm, okay. So you all cannot admit. I only have to admit, right? Okay. I'll make it smooth like for the next session so that it will not interrupt our class. Okay. So So, okay, so there are lots of things like if you want to see how this urban area has expanded in the past, that also you can see. So, from like extracting the data and making GIS maps using GIS tools. So, and also like it is very useful for military purposes, also defense, like monitoring any area, so that kinds of information or application is there for this GIS tool. So it is very interesting. Okay. So let's see. So what type of data that we have in GIS? So we have spatial data. So that refers to location. So any coordinate or address, these are called as spatial data. So spatial means location. Okay. Attribute data is the info of the spatial feature that we have for this particular location. So like for each location that we have, we will be having some spatial feature or that is called as like descriptive information like population or land use. So that is called as attribute data. So the attribute for this particular location will be called as attribute data. So like we have these two types of data, and then the third is relationship and indexing. So this is basically linking the spatial data to the attribute data. Okay, so these are the types of data that we have. So I hope this is clear what is spatial, attribute, and relationship and indexing. Okay. Now, what is the importance? So, it integrates multiple data types, and we can analyze the data like using an assumption that whatever is close to this particular area is kind of behaving similar. So we can analyze like based on spatial proximity or pattern. So this part right now I'm not sure if this is clear, but based on this what we do spatial interpolation. So suppose you have data for India like for like for 100 cities if you have data points and you want to see what is the pattern throughout India. So what we do, we kind of interpolate, assuming that whatever is close to a particular city is going to behave similar. Okay, so that is called as analysis based on spatial proximity. So whatever location is close is going to behave similar. So they will be having similar uh, behavior or pattern. So this kind of analysis can be done in GIS. And this is very important because it can support decision making and understanding real world phenomena. So whatever we do, we are looking at the real world as a layer in GIS. Okay, so if we are interested in soil properties, then we are looking at a soil layer for the real world. So it is basically understanding the real world through a layer in GIS. And it is very useful, like if you see some like sudden changes, it can help in decision making also, like many plots or data points that we have for like climate change, or suppose any area is affecting like every year it is getting affected by flood, then you can like go to the government and ask that this particular area is very susceptible to flood, so this area should not be used for like by people for living, so they should be like it should be declared as a red zone. Okay, so this kind of decision making can be done if you make any GIS layer you to understand the real world phenomena. Okay, so so basically what I am trying to say that this is kind of very important, and you will be like getting lots of real like you will be getting lots of information about the real world, and you can understand it, and it has like lots of application. Okay, so So now uh, we have a question, but answer I showed, but still I'll ask the question. So consider a data set of hospitals in a city. Okay, so suppose we have a data set of hospitals that is there in a city, and it has name, address, and number of beds. Okay, so which of these are spatial data and which are attribute data? So in the chat box you can write which is spatial data and which is attribute data. Okay, so what is the answer? Yeah. So we'll see. Yeah, I think you all are right. So basically, address because it is related to the location, so it is a spatial data. And attribute data is the name of the hospital and the number of beds. Okay, so these are like features that are defining what is there at that particular location. Okay, so this is the answer. Now we have another question. So which of the following is not a spatial data format? So shapefile, geotiff, CSV, and KML. CSV, okay, KML, okay. So it is basically CSV, which is not spatial data format. So in these like three shapefile, geotiff, and KML, the spatial data information is kind of already there. Okay, so once you add like your shapefile or geotiff file to QGIS, you can see like these information like they will be aligned to the map or the coordinate system that is there. But in CSV, you have to like give that information. Like you have to define the lat long and then some attribute also. So it will be having CSV will be having spatial data as well as attribute data also. But these three are basically spatial data format. Okay. So, like in the next session, like we can start with the QGIS, okay? And there I'll show you once I add the shapefile, it will align with the like base map that is there. So it will align with the coordinates system that is there. Same for the geotiff file and KML file, but for CSV, you will assign like you will give lat long information, and also you have to give your attribute like you have to give location name also or some properties also. So it is kind of uh, it will give a table of attribute. Okay, so it is basically attribute table information. So any questions, anyone?
What is KML?
So actually in the next session I will add the KML file, then you can understand. It is basically a kind of file that you can add in QGIS, and so it's hard for me to explain now, but in the
Okay,
next
sure.
class, yeah, I'll add a KML file, and like from like Google Earth or like Google Earth Pro, we can get these kinds of file, KML file you can like get, and then you can add in QGIS also. So that step I can show tomorrow. Okay. Yeah. So now the next question. So which one is not a part of spatial analysis functions in GIS? So spatial analysis means anything related to location or proximity or things like this. Okay. So first is buffering, second is querying, third is editing symbols, and fourth is overlaying. Okay. Okay. So some people are saying B, some are saying C. Okay. So basically, for this question, you don't need to know like much detail about what these are. As any spatial analysis has to do with locations. Okay. So for like anything, if you want to edit the symbol, it has nothing to do with the location. Okay. So this will be the answer. Okay. And buffering is you need to have a shape file, either point or anything like you know what is shapefile or not. Any vector data set. So we will cover that like later on, maybe in today's class only. Yeah, we will cover these things today only. Okay. So let's see. So it will be editing symbols because it has nothing to do with spatial analysis. Okay. And there is overlaying. So overlaying you can only do if you know like there has to be some spatial relationship with which you are overlaying. Okay, so this is basically part of spatial analysis. And querying also like we will cover uh, later. So this also is related to spatial analysis. Okay. So yeah, so querying, let's see, I'll cover this today or not. Mhm. Okay. So querying, I think I'm not going to cover today, maybe, but we'll do this. Okay. So we'll do this. Like there is one session which will basically cover this querying part. Okay. So, the next question is which GIS task allows you to merge two datasets based on shared attribute fields. So buffering, flipping, spatial or attribute join. So this is like kind of intuitive. It will be attribute join only. Okay. So so the next question is what does GIS do in geocoding operation? So these questions are basically why I have kept it because I expect that you have covered first week lectures. So that is why like these terms are coming here. Okay. So what does GIS do in geocoding operation? So what is geocoding? So it will basically convert any address data into geographic coordinates. So suppose there is this information about any address, so it will convert that address in the format of latitude and longitude. Okay, and then this is what geocoding term means. And then the next is spatial indexing. So what is spatial indexing? Why is spatial indexing important in GIS database? So So querying is coming a lot. So what I'll do, I'll tell what querying is. So querying is basically kind of finding. So there are like different kinds of querying. There is spatial querying, then attribute querying. So spatial querying means suppose you are like I'll give you one example. So suppose you are at your home and then you want to find out uh, like you are hungry and you want to find out any restaurant nearby you like so that you can eat. Okay, so suppose if you want to eat, you want to go somewhere that is kind of near you. Okay, so what you will do, you will try to find any restaurant that is within maybe 5 kilometer within your area, wherever you are living, or maybe like if you have some uh, like transportation medium, then you can search for any restaurant that is within 10 kilometers of your location. Okay, so this is what spatial querying means that you are trying to find out any like any kind of place that you want to like if you want to look for restaurants, you will look for restaurants that are within 5 kilometer zone of your area. Okay, so this is what spatial querying is. If you are doing some attribute querying, so it will be doing like only attribute querying will be suppose you are vegetarian, then you will try to find out or non-vegetarian, then you will try, or if you have some preference, then what you will do, you try to find out any vegetarian restaurant in a city, like wherever you are. So that is attribute query. So you are trying to like get information about like features that has this kind of attribute that you are looking for. And then if you join both of them, spatial and attribute querying, so the example will be if you are vegetarian, you will try to find any vegetarian restaurant within 5 kilometers of your area. Okay, so for this, both like spatial and attribute querying, you have to kind of look for both the spatial data, like it should be within 5 kilometers, and the attribute should be that it should be vegetarian restaurant, like not any restaurant. Okay, so this is what querying is basically. So I hope this is clear. So like we have like one lecture that will cover like with the diagrams we have this squaring thing there. Okay, so spatial and attribute. So I hope this is clear. Any doubts? If you have any doubts, you can like write in the chat box, and if it's clear, just message that it's clear. So I hope you know like what is querying. Okay. So why spatial indexing important in GIS? So it speeds up spatial querying and allows efficient retrieval of data. So if you do spatial indexing, like you will have like clear information about the spatial or the location, then it will be easy to find the restaurant within 5 kilometer, or it will be easy to find nearest neighbors uh, of your area. So it will it will speed up the spatial querying and allow is efficient retrieval of the geographical data. Okay, so I hope this is clear. So what are GIS capabilities? So first is data input. So in data input, we can what we can do, we can digitize the data or scan the data or give coordinate entry. Then data management has like you can link two data sets, edit data sets, and import and export data sets. Then manipulation. In manipulation, you can overlay two maps. You can do coordinate transformation also. And analysis contains querying, buffer, overlay, and proximity analysis. So these all features will come in the analysis part. And then we have modeling. So based on the data that we have, we can make a predictive modeling. So and then the last capability is display and output. So that is visualization or thematic map. Okay. So now there is a question. If a health facility is located at uh, location 10, 10 on a coordinate grid, draw or define a 5 kilometer buffer zone around it. So, buffer zone will like what? If it is a point, then the buffer zone is going to be a circular area, and that will be having radius of 5 units. Okay, so it will be any circle which satisfies this particular equation. Okay, so it will basically be a circle. So, basically, suppose this is the point, then your buffer zone is going to be like this. So it will be circular, and the radius is going to be 5 units, and the center is going to be 10 comma 10. So that is why x minus 10 to the whole square plus y minus 10 to the whole square, and this will be less than equal to. So this particular area is going to be buffer zone. Okay, so not like this, but whole circular part is the buffer zone. Okay, so now we'll see what are the different data types that we have in GIS. So first is raster and the second is vector. So raster is basically a data type which has regular grids. So you can see we have these regular grids, and this one grid, like one square, we will be called as cell, and at each cell we have a particular information, like it can have elevation or land use type. Like at each cell we have associated values for this layer. Okay, so this is what raster model is. And like all the rainfall data that you download from MD, like the gridded data one, that are raster data sets. And most of the climate model data sets are raster data sets. All the land use data sets that you will generate is going to be if it is like this, it is going to be a raster data set. Okay, so you can see we have the smallest unit is called as cell, and each cell will be having some associated value. Okay, so associated value. So what are the features of a raster data layer? So it will be having resolution. So resolution is basically the smallest unit of the like cell. So suppose if we go back to this, so this particular cell, it will represent an area on the actual uh, earth. Okay, so what area it is showing, or what area it is representing, is called as resolution. Okay, so suppose this is earth, and this area is 1 by 1 kilometer, and in your image this is your cell. So this particular cell is covering this 1 by 1 kilometer. Okay, so it is taking image of this 1 by 1 kilometer. So whatever spatial area, like the smallest unit area that the image is covering, is called as resolution. Okay, so smallest unit of geographical space which the data is encoded. So if like the resolution or the area, so suppose you have the a data that is 1 by 1 kilometer in resolution, and another data that is like 30 by 30 kilometer of resolution, then which is going to be higher resolution, 1 by 1 or 30 by 30? Anyone? Answer please. 1 by 1. Okay, so 1 by 1, because like within that 30 by 30 kilometer you have 30 points in your image, and in 1 by 1 kilometer, like in 30 by 30 you only have one value, but in 1 by 1 kilometer, for that 30 by 30, so suppose what I will use, yeah, so suppose this is, suppose this is the area 30 by 30 kilometer. So if like it is 30 by 30 kilometer, you only have one value. Okay, but if it is 1 by 1 kilometer, you will be having 30 into 30 values within that area. So you will have more in spatial information as compared to that like coarse resolution data set. Okay, so that is why the like lower the cell dimension, smaller the cell dimension, higher the resolution is. Okay, now zone. So like what we do, we can divide the like areas. If they have like similar values, they can be divided into same zone or same class. Okay, values, so each pixel or each cell is going to have some value, so that is called, like that is values only, and each cell will be having pair of like latitude and longitude values, so that will assign the like geographic coordinate of that area. Okay, and then we also have pixel values. So pixel values are basically like a gray scale. So it's basically what happens is that, I'll show you. Suppose, I don't know why this spike is happening. I'm using this pen. Okay, so suppose this is your raster image. It has 3 by 3, 3 rows and 3 columns. So at what happens for taking this image, what is happening? Your detector, like the satellite detector that you have, is capturing some light. So the area like where like the cell where the detectors are getting more photons or more intensity of light will be having like higher value. So if it is like getting no photon, then zero value will be assigned. If it is getting maximum photons, then 255 value will be assigned. Okay, so this is what this this is called as digital number, DN number, and this lies like for a 8-bit image it lies from 0 to 255. So this basically depends on how number of, like what is the intensity of the photons or the lights that is getting to your detector, okay, from that particular area. Okay, so this is what pixel value is, and for a 8-bit image it will vary from 0 to 255. Okay, so mm, I also have one like small simulator app which is called um, digital image simulator, something like this. So that in that you can see like how these raster images and the values work, and how from like those values we get a colored image. Okay, so maybe in the next class or any class I'll show you like how these images or can give a color. Okay, so can you explain the pixel value again? Yeah, sure. So I'll try to see if I have any image for that so that it will be clear for you. Um, Let me see. Okay, we don't have that, so I'll have to click on. Okay, let's start. So suppose like don't see it as a land use land cover map. Suppose this is a map that you have, and for making this map, what is happening? You have a real world, like this is your ground or earth. Okay, suppose this is your earth, and you have like lots of features here, like forest area is here, then you have a lake or something else, like there are some features, and then on the satellites from which you are seeing this area, what will happen? The light will go from here, from this ground, and it will fall on the detector. Okay, so it will fall on the detector, and then your sensors in the detectors are going to capture the light that is going there. Okay, so suppose this is the image that you get. So at each pixel, the intensity of light will depend on. So suppose you are looking at blue spectrum. So blue light will like blue light will be reflected to this detector, and this blue light intensity is going to vary based on the target. Okay, so if the target is different, then the intensity is going to be different, because some are going to absorb this, some are going to highly reflect this. uh, like if you consider IR, near IR, then vegetation reflects lots of, like healthy vegetation will reflect lots of near IR. So if you will look the near IR image from an area where there is very high vegetation, then that part, from that part there are going to be more number of photons or more intensity of light going to this image. Okay, so based on the number of photons or like intensity of the light, the values are assigned to the images, and that will go from 0 to 255 for an 8-bit image. Okay, so suppose if the IR is getting absorbed, so any water body or anything that can absorb the IR, they will not, like, it will not reflect any IR, so the detector will get zero intensity of IR. Okay, but suppose it is a vegetation area, then it will get high intensity of IR. Okay, infrared. So that will kind of cover, like it can go to the value of 255, like very high intensity. And there can be some features which are going to be like in between these two extremes. So their values can lie like in between 0 to 255, based on how much intensity of light is getting reflected from the ground and getting recorded in the, like, detector of the satellite. Okay, so this basically pixel value, which is 0 to 255, will depend on the intensity of light that is getting reflected and getting recorded to the detector. So I hope this is clear. Okay, yeah, that's good. So anything else, like any doubts so far? So I think we are together, then let's move. So there are various operations that you can do using raster images. So there is neighborhood operation and overlay operation. Okay. So in neighborhood operation, it is kind of um, applying filtering. Okay. So spatial filtering. So in neighborhood operation, what we do, we will use the neighboring pixel to, like, kind of uh, assign a value to the central pixel. Okay, so we what we do, we apply a filter and then we change the value, like that filter will use the um, pixel values from the neighboring area and then change the value of the central pixel. Okay, so so uh, generally what happens is that uh, there are some uh, filtering kernels or matrices that we apply. So suppose if you, like, if you have values like this, and for smoothing, what you can do, you can apply a filter that is 1 1 1, like all the values are going to be 1. Okay, and then what you will do for this central pixel, this one, you will multiply 1 to each of these 9 pixels and then average it out, and then whatever the result is going to be the central pixel. So what it will do, it is like for determining the value of the central pixel, it is giving weightage to the neighboring area. Okay, so it will smoothen the image. And then there is, like, there are some kernels which you can apply, and which kind of uh, like it will negatively, like it will focus on the central pixel, and it will kind of negate the value that you have from the neighboring pixel. So it, this kind of filter is used when you have, like, you want to enhance the edges. So suppose there is change that is happening. So the pixel value from here and here are very different. So if you want to enhance the or increase the difference between these two, then you will apply this kind of filter. Okay, so this filtering operation we will do later on, and it will be more clear by that time. Okay, when we apply this. Okay, so now we'll move on to overlay operation. So There is one example of raster analysis or overlay analysis. So suppose there is some area and you want to identify whether this area is erosion prone area or not. So if you for an area to be erosion prone, it has to have very high intensity and the soil depth should be less, and it also should be having less vegetation. So if there is less vegetation, the erosion can be more, and if the slope is steeper, then also the erosion is going to be more. Okay, so to identify erosion prone area, we have to look at these four variables. Okay, and what we will do is that we will assign, so suppose we will look at the slope map and assign 1 if it is steeper slope. So we can give a threshold that if the slope is greater than this, then assign it 1. And if it is less than this, that means slope is lower, then assign value of 2. So suppose this is layer 1 and these are like all these values that we have are kind of values of the raster image, and they are from like these different locations. Okay, so now we want to know out of this like image which areas are erosion prone. So it has to like cover all, like it has to have all four properties to be erosion prone. So what we will do, we'll assign one that is going to be in favor of erosion prone. So slope 1, steeper slope is going to be 1. Vegetation, if there is low vegetation, then we'll assign 1. Then if the soil depth is going to be low, then we'll assign 1. And in rainfall, if it is high, then we will assign 1. And now we will overlay and uh, say that whatever area that has all four, like all the four layers have value 1, that is the erosion prone area. Okay, so what we will do, we will overlay, and then a layer that is that is having both steeper slope and low soil depth is going to have value of 1. Okay, and also in layer 6, less vegetation, high rainfall, then value 1. And then again we will overlay these two, and then this will tell like wherever there is value of 1, that means it is satisfying all the four conditions that we gave initially. So that is giving kind of area of erosion prone area. Okay, so this is how you can like use four different layers to get like a single layer that is giving the information that we are trying to get. Okay, so this is a kind of raster analysis that we can do. So any doubts till now? Any doubts? So if not, okay. So if not, maybe we can take a 5-minute break and then we'll start with vector data model. Okay, so we are taking a 5-minute break. So if you have any questions, you can write in the chat box. Okay, So for this particular practice session, so I'm recording everything that we are doing, and also I'll upload these like PPTs or PDF of these slides here. So I have an Excel sheet. So for every week, I will be providing YouTube link and presentation folder link, and I also have to give the number of people who are attending. So it's I think 55, I guess. So okay. So all the information and the meeting recording and the presentation folder is going to be provided for you to like practice later on also, and this will be shared through the announcement portal, I guess. So this particular link will be shared maybe from here in the announcement portal, or you can see this problem solving session. Okay, so in the recording, if you go here recording and you click here, you will get to this particular uh, Excel sheet. Okay, and this is where I'll be uploading everything. Okay, so you will be getting everything, but I will encourage you to attend this like in person, because then you can ask questions also. Okay, so I hope that is clear. Any other questions? Okay, so if not, maybe we can start. We have, I think, 40 more minutes, so we can start now. So the next is vector data model. So vector is basically like all the vector data models are kind of either point layers or a line layer or a polygon layer. Okay, so these are called as vector layers, and arcs are the fundamentals in vector GIS, and these points are like locations that are recorded as single coordinates. So this point layer is kind of created when you want to have like some point give point information like cities in India or like hospitals in a particular cities. So for these kind of information, you need to give points where like only like from the lat long you can get to the hospital. So that kind of information is there in this point vector data. Okay. Line layers are basically like if you want to develop a road network or a river network, so then this layers are going to be useful. Then we also have polygon layers. So polygon layers are basically like it will cover any area. So it will be having any properties of polygon and it will cover an area. So it will like Indian boundary. So India, if you want to show India you can show from a polygon layer in a vector. Okay. So these are vector data types, and there are like lots of operations that you can do, like union, intersection, identity, clip. So these vector operations are done uh, using, like if you want to merge information of two vectors, then these vector operations are done. Okay, so these flip vector operation, everything like we will like along the way if we will need to do union operation or symmetric difference or identity, uh, like we will see how you can do this in QGIS. Okay, so maybe I can show you a QGIS interface so that you have an idea which software we will be using. And all these operations you can do in this QGIS. And it is basically open source, so you don't have to have any license for using this. You can just download this software and use it. And for doing this operation, we will be downloading some features um, that we will extract from real like world, and then we will use this. Okay, so I put this open. So it is basically a heavy software, so you need storage. So this is interface of any QGIS software, and you can see any layer. No license is needed for QGIS. You need license for using ArcGIS. So I will also give you a link from where you can download QGIS. Otherwise, if you search on Google QGIS, you can find like the link. Maybe I can show you. Okay. So you just have to search QGIS and know like, so if you want to download in a desktop or any system, you can use it, and then you can download this installer, and or you can also download long-term releases. So it's basically open. You don't need license or anything to use it. Okay. And this software, um, if you want to add any data, you just have to go here. So this is for adding data. So here, like I told you, how to identify raster or vector data. Why? Because if you try to add any vector data, so let me try. So I have added a raster data. I have to add raster data set here. And if I go and add maybe a shapefile, suppose I'm adding any shapefile data, SHP data, and if you try to add it, it will not support it. Okay, so you need to understand like which data is of which type. So whether the data is raster data set or vector data set. So now I'm adding the shapefile as a vector data set, and now if I do it, now we have our data here. Okay, now I'll just try to add a vector data set. So vector, uh, I have water capacity data and all the data sets are TIFF file. So you can see TIFF file. So these are raster data sets. And if you add this, you can see. Mm, okay. So can you see this is kind of Thar extent in the past, and this is the Thar desert area. So what more information can we get? Like these shape files and tip files, they have their coordinate systems. So you can see all the coordinates that we are seeing here are correct. So they already have the coordinates assigned. But if you want to add any like CSV data set, then you have to specify latitude and longitude in the CSV format to add this. Okay, so that is why in that question I said that CSV is not a spatial data layer, but these shape files and these ones are, because they have spatial information. Okay, so this is a raster data set, and this is basically water capacity. So if you see here the legend, if it is white means the water capacity is very high, and that is basically showing the rivers, because there the water capacity is going to be very high. And in a raster layer, if you zoom in, so if you zoom in enough, now you can see these cells or pixels which we were talking about when we are like when I was saying that the smallest unit of a raster is what? A cell or a pixel, and each pixel is assigned a single value. So now you can see this particular water capacity data. For each pixel, we only have one single value, and you can see that value is given by this like color range, gray color range. Okay, so now I hope like what is raster, what is vector, that is more clear, and why we need to identify what is like raster data set, what is vector data set. I hope that's clear. Okay, so maybe we can move on. And also I wanted to show you that in vector we had like lots of operations, right? Like you can do buffer operation, clip operation, difference, dissolve, intersection, union. So these all things we can do, and these are called as vector operations. Okay, and then in the raster operations we have like uh, lots of things like we can do slope analysis, uh, hillshade, or you can like assign, change the projection. So lots of things we can do from. You can clip the rasters data set, you can make contours. So contours are basically the lines which are having similar values. Okay, so those contour mapping can be done using raster dataset, but contour mapping cannot be done using vector dataset. Okay, so these two datasets will be having different kinds of operation, and like later on when we will be using like any doing any case study or using any raster or vector dataset, we will be doing these operations. Okay, so I hope this is clear. And like for the next class, you can what you can do, you can download the QGIS app, and see if you are able to download or are you getting any problem with it. And like as I covered some like hands-on session, you can go and try doing that like by yourself. And if you are getting stuck, we can go through that particular step together in this class, and we can try to solve that problem. Okay, so that thing we will do. So now this there are some advantages and disadvantages of vector and raster dataset. So for raster dataset, what is the advantage? It is very easy to produce. Workflow and analysis is very easy, and it will represent a continuous feature. Okay, so suppose you want to show some feature that is going to have a value at each grid or at each location. You can show that by raster dataset, like rainfall. Rainfall is a property which is kind of continuous. So every location on earth is going to have some rainfall values. Okay, so that continuous property you can show by raster dataset. You can never show like by vector dataset. Another continuous feature is elevation. So every day, like every location on Earth is going to have a particular elevation, and so that is why it is kind of a continuous feature. So every raster data set is going to be like a raster data set can represent elevation also. Now, what are the like advantages of vector? So they are like they can give you discrete geometry. So because it is discrete, it will be the size of this data set is generally very like small, and they are very easy to edit. So there are lots of vector operations we can do to edit the data, and there is logical data structure to it. And like these are some other advantages. Now what are the disadvantages? So like in raster data set we have like something called as resolution. So if suppose you want to look at a feature that is like some some exposure that is there, or some lake that is very small, like 6 by 2 kilometer of lake, and if you choose a satellite image or a raster data set whose resolution is 30 by 30 kilometer, then you cannot see that particular lake. Okay, so the representation of that particular object that is less than the cell size, because you will only have one value. So you cannot get the shape of the lake or anything related to that lake. So this has this limitation that it cannot represent any object that is less than the cell size. Okay, and if you go to finer resolution, then the data set is going to be very large, and you like for discrete features the representation is very generalized. Suppose you want to get boundary of like ocean and land, then using raster dataset it is very like kind of discrete, because you will get some cells that will cover uh, or some pixels that will cover both land and sea area also. Okay, but it is very easy to represent discrete feature using vector dataset. Okay, so continuous, go to raster, discrete, then use vector. Then interactivity and primitive analysis is very less. Then we have some disadvantages of vector dataset. So spatial analysis is possible, continuous data is difficult. Spatial analysis or filtering is not possible. So it is possible for raster but not for vector, and lots of manual editing is required, and uncertainty model is very difficult. Okay, so why I'm focusing on advantages and disadvantages. So in CSIR net exam, sometimes they ask like what is the advantage of raster or vector, or if this feature is an advantage of raster dataset or vector dataset. So you should know like what is the advantage and disadvantage of these kinds of datasets. Okay. And once you start using these data set, you can like kind of understand like how why this is an advantage for this and why this is an this is disadvantageous for this particular data set. Okay. So now there is another data type which is triangulated irregular network. So suppose you want to show a 3D feature like a surface or topography or elevation, then this type of uh, data set is used. Okay, so this is called as triangulated irregular network. Okay, so it uses like these point locations are known as nodes, and the line connecting between these two points are called as edges, and then it forms a triangles. Okay, so these triangles, from these triangles like this network is made, and you can see uh, it can represent any elevation data or topography data. Okay, so now um, we have some questions. So you are asked to digitize the road network of a city. Which model are you going to use? Raster or vector? Anyone? Vector. Yeah, correct. Correct, Sagar? Yeah. So vector model because it will like efficiently represent linear features. So like roads or river networks. So that is why raster model is correct. Now, next question. So I'm happy that lots of people are answering. So it's good. Now, the next question. You have a table with coordinates and rainfall data. With GIS layer type, you can generate from this. So you have table with coordinates and the rainfall data. Which layer type you can generate? Attribute layer, yes, it is like the table which is coordinates and rainfall. It is an attribute data only, but the layer that you will generate is going to be a point layer. Okay, so you are right that this table, this particular table with coordinates and rainfall data is attribute data. Okay, but the layer that you will get is going to be a point layer. So if you plot this, it will be a point layer. Okay, so this we already covered. So now you have to tell me in raster data each cell holds what? A vector direction, a data attribute, a geometric polygon, a node value. Yes, a data attribute. So which file store attribute information in a shape file? So for a shape file, attribute. Yes, correct. So like we added shape file, right? So that was in .shp format. Okay. So now which one of these is not a vector geometry type? Okay, yeah, correct. It's great. Okay, so now we'll move on to data acquisition methods. So, so how can we get data? Like we are plotting or looking at some data, but how we are getting this data? So there are some ground-based data sets, like you go to the field, you do survey, you take some field sensors or go and collect in situ observation. And then there are some image-based, like satellite or aerial sensors, like lidar, radar. So these sensors scan the ground and then they give some images, and from that you can get the data. Okay, so now suppose like we don't have to collect the data, but where can we download these data sets? Okay, so since we will be using QGIS, it is important for us to know from where we will be downloading the data set. So there is this website called Earth Explorer website, so you have to go and log in, and there are lots of data sets that you can download from here. So what I'll do, I'll show how can you go and download the data. So first of all, you go to this site. I'll provide the link. Okay. And now you can see here we have options to select, and here we have the map. So what we can do, you can go to the place like which you are interested in, and then so suppose there is some water body. So suppose we are interested in this particular area. So what you can do, you can either add latitude or longitude. So you can add coordinates or you can use the map. So whatever area it was covering in the map, now it has selected that area. Now you can also define a range, like search from this date to this date. You can also define a cloud cover, so how much cloud cover you are aiming. So cloud cover range should be very less, because you don't want your image to be like, if there are lots of cloud cover, it will cover your ground area. Okay, so what will happen, your image is not going to be as useful as it should be. Okay, so the cloud cover percentage should be as less as possible. So suppose I am taking 23% or 20%, and I can also select like from which date to which date I am interested in, and then go to data sets. So now we have like many data sets. So if you are interested in digital elevation, then you can download this SRTM Arc3 second data. Or if you are interested in, suppose, this Lancet data, like, then you can go here and then select the recent Lancet dataset, so Lancet 8 and 9, and then we can go to the results. Okay, so from the give like for the given period, we had provided 1 month of like range for the date of acquisition. So you can see only one data set is coming out here. If we had provided like broader range, then like it will give lots of data sets. Okay. So now if we want to get the fingerprint, it is going to cover this much area. Okay. And before downloading, you should also look at the metadata. Okay, so metadata is basically like will give you information about how the data has been collected. So metadata is basically information about the data. So data of the data, as we call. So here you can see when like this image was captured. So it was in November 2025 and 5th November 2025, and you can see different things here like what was the sensor type, um, UTM zone, like lots of information you can get. And like if it is like what you are looking for, then you can close it, and using this link you can download, but you have to log in before downloading this data set. Okay, so you need to make an account on this website, and then you can download a data set for your area of interest. Okay, so this is how you download. So is this clear? Okay, so now we'll move on. So from this link you can go to this that particular website and download the data set. Okay, so now there is a question. What does Lancet primarily provide? So we were looking at the Lancet data. So what is that? What it provides? Yeah, it's a satellite imagery. Okay, so that's correct. So it basically has lots of band. Why multispectral? So there are lots of band: red band, blue band, green band, IR range, like a band in IR range. So lots of bands of data is there, and once you download it, you can get like many, maybe 11 bands or 7 bands or 8 bands. And from those different bands, we can get information for that particular area. Okay, so now you have to match the portal with the type of data. So this is like just to uh, like show you uh, like there are different types of portals or different portals from which you can get different types of data sets. So there is this one called Bhuvan, another is Earth Explorer, which like we like just now explored, and there is OpenStreetMap, which you use in your mobile phones, and there is Google Earth Engine. So you have to match like from 1 2 3 4, which is matching with A, B, C, and D. Okay, so yeah, Bhuvan is basically a site which contains information for only for India. So there is another website which is Bhunidhi website. So Bhuvan and Bhunidhi both are containing vector and satellite data for India. Okay, yeah, and yeah, you all are correct. So it's good. I don't have to go through this. So yeah, I was talking about metadata when we explored the USGS website, right? So metadata is basically explaining the data. So how the data was acquired, when, what, where, which satellite, or like every information about the data is there in the metadata. So always before downloading the data, you should read the metadata, because sometimes what happens based on your application, you need like the resolution may be like you are looking at something which is of which needs a very high resolution data, and you just go and download a satellite data which is very coarse resolution data. Okay, so what will happen, even if you download the data like um, it can be very large in size, and after downloading you will get to know it is very coarse resolution, then like your time and your internet, like everything is getting wasted. So why you should waste your time? You should just look at the metadata and it will contain all the information, when it was acquired, like what is the resolution, like from the satellite type you can know what resolution it covers. So always, like before downloading the data, look at the metadata. Another example is that suppose you want to like there was a flood in a particular year. Okay, maybe 2024 or 2025 there was a flood, and you just go and download satellite data, and then you will get to know like even if you do all the analysis on the data, if you don't like look at the metadata, then when that particular image was taken, then you are looking at the wrong data set. Okay, so what will happen, maybe you are looking for the dry season like November, when there was like no flood in that area, or maybe you are looking at the wrong year. So that is why this metadata is very important. Okay, so it will uh, like record information about the constraint, quality, reference system, symbology, everything will be there in the metadata. Okay, so you download a land cover map, but it has no information on resolution, date, or projection. So what key metadata elements are missing? Okay, so first of all, you need to look at the spatial resolution. Okay, so what is the smallest grid or pixel size? Okay, second is you need to know the temporal resolution. So suppose you want to cover or monitor area that has been flooded. Okay, so you need to have a very high temporal resolution data. So like within a day it should cover that area, or like some disaster monitoring if you are doing. So you want quick response or quick data analysis or quick data from that area. So for that you will only look at the data which is like having very high temporal resolution. Means within a day the satellite should visit that particular area 2-3 times, so that you can like have monitor the situation in that area very quickly. So this temporal resolution is very important. Then what is the coordinate system or projection? So coordinate system or projections are very important. Maybe like we don't have much time to cover this coordinate thing today, but we can cover this coordinate system in the next session. Okay, so coordinate system but based on what the projection we are looking at, because like we are looking at a 3D earth, but we only have a 2D map. So for projecting 3D to a 2D map, you do some kind of projection method. And like if the projection method is different, then what happens? Your like data will be misaligned. Okay, then you will have like problems while analyzing the data. So that is why this particular information should be needed, and then the data source from where the data is generated and created, and processing history, like what kind of correction has been done in the on this data. So processing history is important. Okay, so maybe I can stop here. Okay, and I can take some questions if you have. And in the next session, like we can cover geographic and sorry, the coordinate systems and other things that has been not covered today. Okay, so anyone, any questions from any part? Yeah, sure. Actually, I told you from where you can get the recordings. So if you go to this portal, Swam portal, and if you see here, you can get this problem solving session July 2026, and then there is problem solving recording. Okay, so if you go to the recording, you can just click here, and then if you click here, you will get to this Excel sheet, and here for each week I will be uploading the YouTube link and the presentation folder. So presentation folder will be having this presentation. Okay, so you will get this. Okay, so what metadata is? Okay, so metadata means it is basically information about how the data has been acquired, what are the processes has been done on the data, when it was acquired, like what is the resolution of the data, and what is like when it was taken. So these kind of information and reference system. So these kind of information about the data is called as metadata. Okay. So when anytime you have to download a data, you have to just go and look at the metadata. So suppose for this particular data set, you have to look at the data. So it is Lancet 9 data, then which like whether it was nadir of nadir. So what is that start time and stop time? So when the data was recorded or generated or created. So like at which time this satellite was passing through this area while capturing this image. Okay, and like basically metadata is information about the data. So whatever data you are downloading, what is the like history of that data, how it was downloaded, where it was captured, what is the spatial and temporal resolution, what is the projection, data source and creator and history, everything is metadata. Okay, so I hope this is clear. Okay, okay, thank you, Shita. um any questions? So questions, anyone? Okay, so thank you everyone. And it's good that you were answering the questions and you were active throughout the session. And for the next session, if you have like any problems or any doubts, you can just ask me. So before like starting the next session, what I will do, I'll like ask you if you have any questions, and then we can go through the questions and then we can start the session. Okay. So thank you everyone. Have happy learning. Okay. Bye bye.